Welcome back to Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. We're pleased to welcome Scott Maloni, Vice President of Poseidon Water. Scott, welcome to the show.
Thank you. Thank you for having me.
Scott, water is a big issue in California. It's always an issue, but especially now in the midst of a drought. What makes California so special?
Well, I think access to fresh, clean water is an issue all around the world. California over the last 3 to 5 years has been ground zero for this discussion because we are in the worst recorded drought in the history of the state. Some reports say that the state has no more than a year's worth of water left. And a state with almost 39 million residents, the vast majority of which live along the coast and have access to the largest reservoir in the world in the Pacific Ocean, which is always full, and the technology exists to treat that water for human consumption.
So I'd like to get into that, but first dig a little bit more into not just the supply side of the problem, but the demand side of the problem. One of the things California does not have is market-based water rates. Why is that?
That is true. I mean, one of the challenges with water is it's essentially free. And so it's not treated as a commodity, and it's not treated as a resource that should be conserved. And so it is used in abundance. It's not recycled sufficiently. Mm-hmm. And so when you're not paying the true cost of a resource, you end up having a supply and demand problem. And that is exacerbated in California, where the vast majority of the population is in Southern California, and the water resources that serve that population are in Northern California or in another state in the form of the Colorado River.
So what attracts somebody to go into a business to sell a relatively expensive commodity and compete against free?
It's really supply and demand. It's births over deaths, and it's the need for new water resources in the population centers that are growing in California. I mean, Poseidon is a privately held company. This is our 20th anniversary. We are in the business of financing and developing water infrastructure projects. And since the late 90s, we've been developing 2 large-scale seawater desalination projects in California that are designed to diversify the water supply portfolio.
So you've been at this since the late 90s. Has anything been constructed yet?
We have, again, 2 facilities, and they're both 50 million gallon per day seawater desalination plants, which would make them the largest in the Western Hemisphere. Mm-hmm. Our Carlsbad facility is under construction. It's about 95% built and scheduled to be online before the end of this year.
That's great. Now, so far, I think Israel is the world leader in desalination. Are they not?
They are. Israel has 5 large seawater desalination plants. It provides about half of the drinking water supply for the state. But they've also invested heavily in water recycling and innovative technologies for the agricultural industry. So they really are a worldwide leader in water resource management. And they're not alone. I mean, you're seeing Australia make significant investments in seawater desalination as well as agricultural innovation. But what I think people are coming to understand is that there's a limited supply of fresh water available. And as the population continues to grow, and the world economy continues to grow, we need to develop new supplies. And seawater desalination is a proven technology around the world, and it's just a matter of time before it plays a bigger role in North America in terms of providing potable water supply.
Give us a little background on the current technology behind desalination.
Sure. Today, there's over 15,000 seawater desalination plants in 150 countries around the world. The technology of choice for large-scale seawater desalination plants is reverse osmosis. And a lot of people can go to their Home Depot or their Lowe's and get a little RO unit and put it under their kitchen sink. Essentially what the technology is you're forcing the water under pressure through membranes that have holes in them that are 100,000 times smaller than the diameter of a human hair. And the only molecule that can fit through is a water molecule. It rejects the salts and the impurities. And so you extrapolate that technology on a large scale, and you're able to produce large quantities of drinking water.
But it does take a fair amount of energy to do that. How much energy does it take to produce a gallon of water?
It's on the magnitude of about 3,200 kilowatt hours per 1,000 gallons.
Per 1,000 gallons.
But you have to remember, in California, the sources of our drinking water are imported, meaning they come from the north, they come from the east. And that water has a significant energy load embedded in it. And so while seawater desalination is slightly more energy intensive than those alternative supplies, one of the areas where the technology has really evolved over the last 20 years and why it's much more cost competitive today is it's not requiring as much energy in the form of electricity to remove the salts from the fresh water. In fact, the current membrane technology that we are using in Carlsbad, which is state of the art, requires about 50% less energy consumption than just 10 or 15 years ago.
Right.
And so when you can reduce your energy consumption with the RO process by that much, you're really reducing your overall cost.
Let me see if I heard you right. It takes about an hour of running a 100-watt bulb to get a gallon of water?
And that's about right. And just to put that into perspective, one of the policy issues that arises when you talk about water resource management and seawater desalination particularly is energy consumption. I would argue that water, the most basic element of life, should have a higher priority in terms of energy consumption than some other uses. For example, a data center that allowed your internet to go, a tenth of a second faster.
So, Scott, you've just crossed over into politics, which is what the world of California is all about, setting priorities in the absence of market mechanisms. Talk to us a little bit about how long it took to get permitted and approved for these plants in California.
Sure. Again, our projects were introduced in the late 90s and where Carlsbad will be under construction by the end of the year. But it was approximately a decade in the permitting process, and throughout that period of time, there were 14 legal challenges filed by coastal environmental groups who, quite frankly, view seawater desalination as providing a drought-proof, reliable water supply, and their concern is that would lead to growth. And these are anti-growth organizations that don't want to see California's economy or its population grow at all.
So their goal is to keep the region parched so they can chase people away and keep California for themselves.
And the way to do that is to limit the availability of water. And so if you compare the permitting process that we went through to a power plant built along the coast, it's apples and oranges. While it took us a decade to get Carlsbad through the process, a similar industrial facility, power plant facility, could probably complete that process in 2 to 3 years. Power plants have in California what we commonly refer to as a one-stop shop permitting process, meaning they can conduct all their environmental review and discretionary permits through the California Energy Commission. Conversely, a seawater desalination plant, which has a similar environmental footprint, has to collect a half dozen different local, state, and federal permits. And the environmental review process is duplicative. And every step of the way, you have a legal challenge by some group that has a political agenda.
So there's a lot of people who can say no.
A lot of people that can say no, and a lot of people who are duplicating environmental analysis and review that has already been conducted.
So what does this do to the cost of operating the plant if you're spending so many years just trying to get the permits?
It has an impact, but it's not so much an impact in the cost of the water as it's a barrier to entry. And so Poseidon is the only privately held company that is developing large-scale seawater desalination projects in the United States today. And the impediment for public agencies would be the burdensome permitting process and the expensive permitting process. And so unless something changes in California to make that process streamlined, you're probably not going to see a lot of players in the industry. You're probably not going to see a lot of public agencies willing to invest the time, resources, and money to develop large-scale desal plants.
Well, barriers to entry are a double-edged sword. They're horrible when you have to climb over it, but once you're on the other side, it keeps your competitors out.
Well, that's true, and I think that's what gives Poseidon a competitive edge. We have successfully permitted, financed, and are about to complete construction on the only large-scale desalination plant in California and the largest in the Western Hemisphere. We're very close to repeating that success in Huntington Beach, which is about 60 miles north of Carlsbad. And so we do have a unique market position, not only in California, but in the United States. Many people will tell you if you can permit an industrial facility along the coast of California, you could probably do it just about anywhere.
So, Scott, what do you see as the next big hurdle you're likely to clear?
Well, as I mentioned, Carlsbad will be operational before the end of the year, but one seawater desalination plant isn't going to move the needle in California. We have a second facility in Orange County, about 60 miles north of San Diego County, 50 million gallon per day facility virtually identical to Carlsbad, which requires one last discretionary permit from the California Coastal Commission, which is the 800-pound regulatory gorilla in California. We expect to be before the Coastal Commission before the end of this year. And with approval of that permit, Huntington Beach will be the second large-scale desalination plant built in California.
So oddly enough, this drought has turned out to be your best friend.
Yes and no. It certainly has focused attention on the need for a diversified water supply portfolio. However, we've made it abundantly clear that these projects are not drought response projects. I mean, it's taken us 10 to 15 years to move them through the regulatory process. We've been through 3 droughts during that period of time. And in terms of Huntington Beach, by the time it's built, we'll probably be out of this drought and into another drought. So there's certainly drought-proof water supplies, but they're not being built for a particular incident or occurrence in time. These are projects that will provide reliable local water supply for half a century.
So, Scott, you've cleared a number of environmental hurdles, but what about hurdles put forth by people that want to protect the taxpayer? I understand that the public-private partnership approach you've taken shifts a lot of the risk onto taxpayers.
Actually, it's the opposite. The public-private partnership approach shifts cost and risk from the taxpayer to the private sector. And it's somewhat of a unique model in water infrastructure development in North America. Typically, you'll have a public agency develop, finance, construct, and own and operate a water resource, a treatment plant or a reservoir. In our case, Poseidon is assuming all of the financial cost and risk with the siting, permitting, designing, constructing, financing, operating of the desal plant, and we enter into a long-term, fixed-price contract with the public water agency where all the water is appropriated for public use, meaning the water agency doesn't pay for water unless we can deliver it, meeting contractual specifications for quantity, quality, reliability, and price. And so that unique kind of P3 approach to water infrastructure has been a real success in California in terms of our Carlsbad desalination project. We're in the process of replicating that P3 approach up in Huntington Beach, and we think it's really the model moving forward for developing large water infrastructure projects.
So let me understand the framing of this, because it's really a glass half full versus a glass half empty view. In a purely public approach, the taxpayer takes all the risk from the beginning. In a purely private approach, the taxpayer takes no risk whatsoever, and the private company just has its way in the market. So what you're saying is this is halfway between, making it a much less risky deal for taxpayers.
We think so because there's a lot of risk with the permitting and construction and operation of any infrastructure project. I mean, how many headlines have you read over the years about a public works project being, over budget and past the deadline of delivery? All of them, right? Almost all of them. So in this case, the ratepayers are insulated because they don't have to pay until Poseidon can deliver the water. And when you're talking about developing infrastructure projects along the coast of California, there are all kinds of pitfalls along the way to the point of where you could deliver your commodity or your resource. And so Poseidon, as a private company, spent tens of millions of dollars just getting to this point in time in Carlsbad. Ratepayers are insulated from all that. They haven't had to have any increases to their water rates for a project that may or may not have been permitted, may or may not have been financed or constructed and operated efficiently. And so we think it's a real win-win for Poseidon because the benefit for us is if we meet all those contractual requirements, then we have a long-term revenue stream to pay off our debt, and we have a customer for the life of the project.
And how does one take a commodity and construct a 30-year take-or-pay approach? I mean, what's the price of corn going to be 30 years from now? We have no idea.
Well, you establish a fixed price take-or-pay, and then it escalates on an annual basis on pre-negotiated indices. In the case of Carlsbad, we've tied the O&M, the operations and maintenance of the plant, to the local CPI, Consumer Price Index, and that annual escalation. And then electricity. I mean, electricity makes up about 25% of your total cost or about 50% of your operating cost. And so on terms of electricity, that's not a cost that Poseidon can control. We guarantee the energy consumption of the plant, meaning that the efficiency is guaranteed contractually, but the utility electricity rate, which floats from year to year, that is a cost that is absorbed by the customer. And if you look at the annual escalation in electricity rates over the last 20 years, it averages about 2%. And if you look at the alternative of importing water from Northern California to Southern California, that cost over the last 35 years averages about 6.5%. So our approach, where we can lock in the capital recovery at a fixed rate of return and tie the O&M to known local indices, we believe will result over the life of our project in the ratepayer saving significantly over the alternative of having to completely get their water from imported sources. On top of that, you have the benefit of a drought-proof, reliable water supply, which is not a characteristic that anyone ascribes to imported water.
What happens if a new technology comes along that vastly reduces the costs?
Well, that's a contractual negotiation, but the way that would work in the contract we have in San Diego is that would be a savings that would be shared with our public water agency customers. So if, for example, if the membranes improve and you can cut the cost in half, then that's something we would share with our customer.
So on the electricity side, if California energy policy drives up the cost of its electricity dramatically pursuing green initiatives, it's going to cost them in water too.
That is true, but there's an embedded energy cost in all sources of water, so wouldn't be unique to seawater desalination.
Scott, let's dig a little deeper into the true cost of water because current policy makes it so hard to understand what that is. Break it down for us for desalination, but also compare it to the true cost of providing water conventionally.
Sure. One of the challenges with conventional sources of water, the true costs are hard to discern and hard to know. Ratepayers don't actually pay for the water. They pay for the treatment and transportation of the water, but the water itself is, in California, is free. Seawater desalination is probably the most transparent cost of water available in California today. And right now, in California, in our Carlsbad project, we can produce and deliver a gallon of drinking water for about a half a penny.
Wow.
A half a penny a gallon. Compare that to what you might pay for a bottle of water at a grocery store or a soda or a beer, or compare that to your cell phone bill or your internet bill. Yet water is the most basic element of life. You cannot go more than 3 or 4 days without water. We think a half a penny a gallon in the most transparent costs available is a reasonable price to pay for fresh drinking water that is drought-proof and locally controlled.
It sounds great for a water consumer, but maybe not so great for an almond grower.
That's a fair question. However, seawater desalination is not a silver bullet. California and no other state is ever going to replace all of their traditional water supplies with seawater desalination. So in San Diego County, for instance, our project represents about 10% of the overall water supply. And it's valuable because it's locally controlled, it's drought-proof. Many people refer to it as an insurance policy.
Sure.
But when you factor in a half a penny a gallon for 10% of your water supply, and maybe some other sources are a tenth of a penny a gallon, your overall rate impact is manageable. And again, you got the value of the diversified supply and the insurance policy of the local drought-proof control of the desal.
Is any of this water actually going to go to farming, or is it mostly just going to go into the municipal water supply?
It's going to be blended in. So the Water Authority, San Diego County Water Authority, who's the customer, 30-year contract for the Carlsbad project, will take all of the water and blend it in with its other supplies, and then it'll flow throughout San Diego County. So you're not going to be, as a consumer, whether you're in the agricultural industry or you municipal and industrial consumer, you're not going to be able to distinguish the difference between desalinated water or other sources.
So, Scott, what does the future hold in terms of new breakthroughs in research and development in desalination?
Yeah, that's a great question. And a lot of people are starting to turn their attention to R&D and seawater desalination. In fact, United States Senator Dianne Feinstein will be introducing a water bill later this year that looks to invest federal government money in additional research and development. A little known fact is that the international seawater desalination industry is here in Southern California, and it grew out of General Atomics' investment in the RO technology back in the 1950s. The first commercial seawater desalination plant was built here in San Diego County and was then shipped off to Cuba because President Kennedy was concerned that Castro was going to turn the water off to our troops.
Huh.
And so over the last 50 years, that industry has really grown. And the manufacturers of the RO membranes and the housings and the various components of the desalination process are all investing in kind of the next generation of reverse osmosis.
Mm-hmm.
And you see companies like Lockheed Martin looking at the application of graphene for a membrane.
Mm-hmm.
And I think what you're going to end up seeing is that you could probably expect in the neighborhood of 20 to 25% more efficiency to be wrung out of the system, so to speak. And so many people believe that over time, as our traditional water sources become more expensive, desalination will either stabilize or become less expensive as you see additional evolution of the technology.
Are there any economies of scale as you build more of these plants?
Yeah, there certainly is. I mean, the larger your facility, you see more economies of scale. If, just for an example, if you took all of the reverse osmosis membrane in our Carlsbad facility,
mm-hmm.
and they're spiral wound in membrane filters, but if you rolled it all out in a straight line, it would connect from San Diego to the Oregon border. I mean, these are large facilities,
wow.
and you certainly have economies of scale when you're talking about modular, automated
mm-hmm.
industrial processes. And so just rough magnitudes of order. As I mentioned, water costs about a half a penny per gallon in our Carlsbad facility,
mm-hmm.
and that's producing 50 million gallons per day. If you cut that in half to maybe a 25 million gallon per day plant, you would still have sunk capital investment that would be spread over the smaller unit production. So you'd probably see that half penny go up to, three-quarters of a penny or maybe even a full penny a gallon.
Well, plus all the permitting aggravation.
Yeah, that's a large part of it. And just it's not easy to find land along the coast of California that is appropriate for industrial development. And so when you do find these pieces of land, you're going to want a large parcel, and then you're going to want to build a large facility on that parcel.
Now, you've cited these facilities behind existing power plants, have you not?
Yeah, I mean, that's part of the business model. Is when we first introduced these projects in the late 90s, the idea was to co-locate with existing power plants that use seawater as part of the electrical generating process. And the concept was we would use the discharge from the power plant as our source water.
Mm-hmm.
So after the power plant has used seawater to condense the steam-powered electrical generators, we would redirect that already used wastewater,
mm-hmm.
so to speak, from the electricity process to our RO plant, where you could treat it for human consumption and pipe it into the regional distribution system. California, about 6 years ago, decided to essentially regulate those power plants out of business. And so there are about 19 power plants along the coast of California that for 50 years now have used seawater as part of the electrical generating process. And all those power plants are in the process of decommissioning their cooling water systems and rebuilding using new technology. But they are all leaving behind existing seawater intake and outfall facilities, which provide an opportunity to co-locate seawater desalination plants and continue to use those facilities. It's not as efficient as using them when the power plants are still operating, but the existence of those facilities will make seawater desalination a lot more economical, because if you had to build a new seawater intake and outfall on the coast of California, not only would the regulatory climate be prohibitive, but it would be probably economically prohibitive.
Are there any nuclear power plants sited near the coast that you can use the same approach?
There are two. One in North San Diego County at San Onofre has recently shut down. There's a second, Diablo Canyon, which actually runs a very small seawater desalination plant for its own use. And there's been some discussion about expanding that facility for municipal and industrial use.
So, Scott, paint us a picture of the years ahead.
Well, I think that the success of the Carlsbad seawater desalination plant and the public-private sector approach to delivering that facility will change the way that we look at water infrastructure development in California and in the United States. And not just seawater desalination, but wastewater treatment plants and other treatment plants. I think we're in an age where the government can't afford, especially regional and local government, cannot afford to invest in infrastructure projects. And there is a significant amount of private money out that is willing to invest in these facilities if the opportunity exists. And I think what Carlsbad will show private investors is that there is an opportunity out there. And there certainly will be more seawater desalination plants built in states like California and Texas and Florida. But I think where the real future is going to lie is wastewater recycling. And I think you're going to see a lot of interest in P3, public-private partnerships, in development of wastewater recycling plants.
Well, Scott, thanks for the education, and thanks for coming on the show.
Thank you.
That was Scott Maloni from Poseidon Water, here on Real Clear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. Real Clear Radio Hour is produced in conjunction with Real Clear Politics, America's premier independent political website. Real Clear Radio Hour is a not-for-profit, donor-supported program, now airing in 10 cities nationwide. If you'd like to help us expand, please stop by realclearradio.org and hit the donate button, or contact us to become a corporate supporter. That wraps up our show for this week. Join us next week, same time, same station. See you then.